In this video, we're going to look at binary operations. So when it comes to binary operations, the term itself binary comes from the fact that we are having two elements. We are having two elements, or we are dealing with two elements. Thus, the usual arithmetic operations, that is addition, multiplication, subtraction, and multiplication, are examples of these binary operations. And so when we choose two numbers, so when you choose two numbers in such a way that, in a general way, such that when you work out those two numbers, you are able to get a third number, which is a member of the underlined set, then that operation which you use to get that third number is called a binary operation. So other binary operations include things like union of a set, and intersection of a set. So A union B will give you what? Let's say C, give you a set C. So when you combine both elements, A and B, then you call that set to say what it is, set C. So it's an example of a binary operation. You're involving two sets in this case. Then same with the intersection, like that. Then you get, let's say, the set D. So you're involving two sets. So but then we shall use a symbol star. We shall use a symbol star like this to represent the generic operation of, or to represent a general form of the binary operations. So we'll just use a star to represent a general form of the binary operations. So let's say we have a set S. Then this set S is equal to A, B, C. It's going all the way. Then we are saying the operation, which we are using in general, star, is going to be a binary operation on this set S if and only if, for every ordered pair of elements that we choose, that is A, B, where this A and B are part of the set S, then there is an assigned an element A star B going to be a member of this set S. So this is how we are going to denote. Then we're saying we're going to assign a notation in general to say, when we have this A B, then we're saying A star B, like this. This A star B must be also a member of the set S, or the underlined set which you're talking about, or the underlined field which you're talking about. So now let's have these questions. So we're saying there are these questions here. Let the binary operation star be defined. So it's defined as A star B to be equal to A plus B plus 2AB. So this right side is what we're defining our binary operation to be like. So then we are told to find A 5 star 2 star 5 and negative 5 star 3. So how are we going to do this? So to find this, we'll just say A is going to be, so binary operations, when we say A star B, which is just going to be, our A in this case is 2 and our B is 5, and this is going to be where there's A, I replace 2, and where there's B, I'll replace 5, and that will apply everywhere where A exists, where it appears, then where B also appears, like that. Then they are binary operations, meaning I can only perform perform two assists at a go. So if there are elements here where I have these two numbers, I can only add the two numbers at a go. I can only multiply the two numbers at a go, just like that. That's how you do these binary operations. So in this case, when I have 2 plus 5, I get 7. So you cannot do, you say you're adding and multiplying at the same time. So you have to perform just a single operation. Let's say if you are adding, you add the two numbers, or if you're multiplying, you multiply the two numbers. So this will be plus 2. I can multiply these two here. I'll get 10. Then when I multiply that, I'll get 7 plus 20 like that. Then I can add this, then I'll get 27. So this is how I find that question. Then let me do the other one, which is negative 5 star 3. Negative 5 star 3. So where there's A, I'll put negative 5. Where there's B, I'll put 3. Then I'll have 2. Where there's A, that will be negative 5. Then where there's B, I'll put 3. And this is going to be, when I add these two, I'll have negative 2. Then when I multiply negative 5 and 3, I'll get negative 15. Then I'll have negative 2. I'll multiply here negative 2 by negative 15. Then I'll get negative 30. Then when I add these two, I'll get negative 32. So this is how you find these two questions. How you solve these two questions. Okay. So now let us move on. So in general, we can see from what we've done that when we have A star B is not equal to B star A. A star B is not equal to what? To B star A. So for these ordered pairs A comma B, it's not always going to be that A star B is going to be equal to B star A. So it's not always going to be equal like this. So when we have, so we can see this like if we have if we are dealing with matrices, we have a matrix we have a matrix A and a matrix B, then we are told to find A, we are the product of A and B. This is not always equal, this is not going to be equal to the product of B times A. So it is only in a special case where these sets are equal, like A and B, when that is going to be what. But now in this case, this won't be the same, this won't be equal. And we can see now that, okay, we can see that we were just talking about addition, subtraction, and multiplication. And then what of when we talk of division? So is this the division the division operator being a binary operation? Is it a binary operation under the field of so the field that we're considering is the integers? So is it a versus? So we see that this will not be a binary what operation, because when we perform, for example, let's say we have two numbers 6 and we have the number 7, 6 and 7, then we performing this. So we see that when we divide here, we will not get what? An integer. We are going to get a rational number. So says for it to be a binary operation, you must get a number that is going to sit in the same field where you got those numbers. So this does not qualify to be a binary operation. And so we see that in some cases, okay, so we see that in some cases, even at times, depending on how your field is defined, even the subtraction cannot be what? A binary operation. Now let us look at some cardinal things that will be very useful in our study of binary operations, which are commutativity and associativity. So a binary operation, this binary operation star, is said or is called commutative, is said to be commutative if and only if, so if and only if for the pairs A comma B in the set S, A comma B in the set S, I have that A star B is going to be equal to B star A. So this then binary operation will be called commutative. It's going to be commutative. And we can see that from the binary operations, let's say we have a binary operation of addition and multiplication. So for the set of real numbers, we see that this commutativity rule is going to hold, because when we say A plus B is going to be equal to B plus A, addition is commutative. And when we say A multiplied by B, it's the same as B multiplied by A. So since these are just numbers that we're picking from, real numbers from the field of real numbers, this is going to hold. But that is not the case for subtraction, because if we say we have real numbers, let's say we have real numbers, we have the real numbers, let's say we have 7 and we have 5. So these be a member of the real numbers. Then when it comes to subtraction, we can see that 7 minus 5 is not equal to 5 minus 7. So this here gives me 2, and the other one, the other side, gives me negative 2. So we see that this does not what does not give us the same thing. So it cannot be commutative. Now, what do we mean when we talk of the other term, which is associative? Associativity. What do we mean when we talk of associativity? So the binary operation star is said to be associative if for a triple, let's say we have A, B, and C being a member of the set S, then we have A star B, so A like that, and B star C being equal to A star B star C, like that. So when this is what is true, or when this holds, then we say that the operation is a binary operation. The operation is, the operation is associative. The operation is associative. So we can see that uh, addition, so here addition and multiplication, so addition and multiplication are going to be associative, but for division and subtraction, this is not the case. So let's say if we have 12 minus 8 minus 2, so we see that this here is equal to, what do we get when we operate this? So when we subtract 2 minus 8, I'll get negative 6. Then I'll say 12 minus 6, that gives me 6. So this is not going to be equal to, if I say I do the first two, if I say 12 minus 8 like this, then I say minus 2. So here inside I'll get 4. Then 4 minus 2 just gives me 2. So this is not the same. I don't get the same thing. So that operation of the binary operation, the minus here, negative, minus is not going to what? Subtraction here is not going to be associative. Then when it comes to division, we can see as well that, let's say if I say 24 divided by 6 divided by 2, this is going to be equal to, so when I divide these 2 here, I will get 4. 4 divided into 24, I'll just get 8. And this is not equal to me first dividing 24 divided by 6. I know there I'm going to get 4. Then when you divide it by 2, 4 divided by 2 is going to give me 2. So these are not going to be equal. So we see that this operation is not what? Associative. Now let us look at one question to close the video. So we have this question here. It says the binary operation star on the real numbers is defined by A star B being equal to A minus B squared minus A B. Then we are told A, determine whether the operation star is commutative. Then B, one saying evaluate that and evaluate the other one. Then hence state whether the binary operation star is associative or not. So how are we going to do that? So to show that it is commutative, if we have A star B, it's equal to A minus B squared minus AB. So we must get a form in which we, from this same one, we must manipulate in order to get B star A. So how are we going to do that? So here you are going to swap. So you swap this negative B, then plus A there. Then this here square minus B A, like that. Then we see here that we can factor out a negative. So when you factor out a negative there, you get negative, then you have b minus a, like that, then squared there minus ba. So here when you square, so this is just like 1 squared is going to give us a positive 1. Then here you get b minus a squared, then minus b a, and this is the same, or this is equal to a star, this is equal to b star a. So this shows that this binary operation here is commutative. Now we are told to evaluate those questions. B says evaluate those questions. So how are we going to do that? So in order to evaluate, we say the first one says negative 1 star 3 star 2. So what you do is you work out first this first part which is there in the brackets, then you work out the one which follows. So let's replace. So this negative 1 is going to be my a, and 3 is going to be my b. So I have negative 1 star 3 equal to, so that is going to be negative 1 minus 3, then squared minus then what is my a? My a is negative 1, then I have my b to be 3. So this here is going to just give me, it's going to give me, so that will be negative 4 squared, then I have minus, so here negative 1 minus multiplied by 3, I'll get negative 3, and this is going to give me, when I square 4, I'll get 16 minus 3, then that gives me 13. Okay, so from here then it means I have 13 star 2. 13 star 2. So now how am I going to work out that one? So what I do, in this case, so my a is 13, and my b is 2. So I'll replace. So I have 13 minus 2 squared minus 13, then this is multiplying by 2, like that. Then I'll get so 13 minus 2, I'll get 11 there. So 11 squared, then that will be minus, so 13 by 2, I get 26. 13 by 2, I get 26. Then 11 squared, I get 101. 101. Okay, so I get 101. So then I subtract there minus 26, then I'll get 95. So this here is going to give me 95. So this gives me 95. So let's keep the 95 because of the question that is following. So we keep the 95 there. Let us solve B. So B then, okay, B, it's negative 1 star 3 star 2. So we start with 3 star 2. So that is going to be 3 star 2. It's going to be equal to, while there's a, I replace 3 minus b2 squared minus 3. My b is 2, like that. Then I'll get this to be equal to, when I subtract there, I'll just have 1 squared minus that gives me 6 minus 6. Then I'll have negative, this will give me negative 5. So now I have negative 1 star negative 5, and this is going to be equal to negative 1 minus b. Our b is negative 5, so that will be plus 5, then squared minus negative 1 multiplied by negative 5, like that. Then here what I'll get is, when I work out what's in the bracket there, that gives me 4 squared minus when I multiply negative 1 and negative 5, I get positive 5. Then squaring this, I'll have 16 minus 5, and that just gives me 11. So this gives me 11. So that's your answer here for 2. But then the question continues to say, hence state whether the binary operation star is associative or not. So we see that 95 that we found in the first one is not equal to 11. So this means that this binary operation star is not associative. So this is how you work out binary operations.